All right. It's the moment you've been waiting for pretty much all school year, probably. You've been wondering what 13.5 was going to be about. Mystery solved. It's about the law of sines. So that's pretty exciting, unless you don't know what it is. We have been studying triangles. We have been studying triangles since you have been studying at home. And we've been living over here in this little corner of the world where we keep right triangles. And we've been using things like SOHCAHTOA for a whole bunch of things. We've been doing unit circle, we've been solving equations, but back in the day, we just used SOHCAHTOA to help us find the sides of a triangle. And we used inverse sine, inverse cosine, and inverse tangent to help us find the angles. So we've been doing that for a really long time. But the reality of life is that there are triangles in the universe that are not right triangles, and they are called non-right triangles. So I feel like that's pretty creative. So the deal with non-right triangles is you no longer have all of the solving methods you had before, because you now have a situation where a squared plus b squared does not equal c squared. So you can no longer use that to find your sides. So you need some new tricks. We're going to learn one trick today. We're going to learn some tricks about that trick tomorrow. And then we're also going to learn law of cosines next week, which happens to be the last fun thing you get to learn in my class, which is really sad to me, but we'll deal with that later. So the law of sines is going to live over here, and the law of sines looks like this. If you have a non-right triangle, let's call it, A, B, C, it doesn't make a difference who goes where. Capital letters are always going to represent angles. And then if you go straight out from that angle, you're going to hit the side across from it and call it the same letter, but lowercase. So if you leave angle C, you'll come hit here. If you leave angle B, you'll hit this side over here. So the sine of this angle A over the side across from it, the relationship, ratio, fraction value of that will equal the sine of angle B over side B and angle C, sine of angle C over side C. So we're really just saying that the ratios are all the same. This angle over the sine of this angle over that side, the sine of this angle over its opposite, and the sine of C over its opposite. So you don't obviously use the formula with 3 parts and 2 equal signs. That would be uber confusing. But you will know one of these pairs, and that's the catch. How are you supposed to know if you've decided that it's a non-right triangle, so there's no 90, that you're supposed to use the law of sines? Well, the way you're going to know is that you were given, and so you will know a big A, big B, little b, or big C, little c. So you have to know an angle and the opposite side, like the side across from that angle. Those are required pieces of information, otherwise you can't use the law of sines, and you'll be jetting over here to the law of cosines, which we'll learn later. So in the interest of making it less confusing for those of you who like to use the filled in notes and such, I'm going to take, the reason I'm not using the filled in notes from the packet directly is that we're breaking it down into several days rather than doing it all in one day like we would in real school. But I am going to go ahead and use these examples. So the first example in my notes packet, when I go to write these out, I always, always, always write the angles, the angles and then the sides across from each other like this. So here are my angles because they're capitalized, and here are my sides because they're lowercase. And I'm reading off of the notes packet. B is 34 degrees, so that's big B. It says big C is 100 degrees, and then it tells me that little b is 8. Okay, so these are the 3 things that I'm going to find. So what I'm going to look at is this and say, hey, I have big B, little b. I know an angle and its opposite side, so I'm able to use the law of law of sines, which seems obvious since that's what the notes are about. How do I use it though? Well, I don't know anything about A, so I'm going to go ahead and find side C. So that means I'm going to be using this part. Oh, I'm sorry, this part, because I know angle B, so I'll have the sine of angle B over side B. And then I'm using this because I'm looking for side C. So that would be the sine of angle C, which is 100 over C. And now this, you should start to look at and think, okay, I could probably cross multiply that, which you can do. So we're going to do that. We're going to take 8 times the sine of 100 and make that equal to c times the sine of 34. But since I want c alone, I'm going to divide that sine of 34 over to the other side. And depending on how comfortable you are with cross multiplying, you might kind of do that all in one fell swoop. So I grab my calculator. I'm going to be a little bit careful about my parentheses. I'm going to take 8 times the sine of 100, and then I need to close that parenthesis so my calculator knows that's all I want the sine of. Then I'm going to divide by the sine of 34. And I'm getting 14.0889, and the directions said to round to the nearest hundredth. And so C is going to be 14.09. And it's important to pay attention to that now that we're in the age of entering your answers into the computer to be graded, because it only accepts the one right answer. Now, I'm supposed to find everything. How do I find this? I told you that a squared plus b squared no longer equals c squared because it's not a right triangle, but the angle relationships still exist. These still have to total 180. So if I take, to find angle B, if I take 180 minus the 100 and the 34 that I already have, it will tell me what that last angle must be. And that last angle is a 46-degree angle. Awesome. Well, then how do I find side A? Can't use Pythagorean theorem because it's not a right triangle. So I have to use law of sines again. Here in this one, we used this to find little c. Now we're going to repeat our math to find little a. I'm still going to use the one that was given. I'm still going to set up with the sine of angle B over side B. Then I'm going to have the sine of angle A over side A. And then you'll cross multiply again. So the math gets actually pretty repetitive, and you're going to find it hopefully to be pretty easy. And so I'm just going to write this out in case you're not finding it to be really easy. So little a is going to equal, now Boone is going to take a drink and be really loud, 8 times the sine of 46, close that out, divide by the sine of 34. And so side A is apparently 10.2, and I'm being careful here with rounding to the nearest hundredth because I'd probably have to enter that in on my calculator. Now, one thing I can do to see if my answers are logical is take a look. This is my smallest angle, so it should be across from the shortest side. This is the medium angle, so it should be across from the medium length. And then this is my my largest angle, so it should be across from the longest side. So that at least seems logical. So there's a couple different steps that I'm taking. I'm using the law of sines to find this side, using it again to find the other side. Here, I'm just using the fact that angles still add up to 180. So you're going to have to employ a couple different things as you tackle these problems. Alrighty, I'm going to do one more example and then let you try your homework. So if I see the triangle drawn, that's not how my brain works. So I will go ahead and write this out. I write the angles here. That's cute. Miss Meyer obviously made this. And then I write the lowercase letters across from it. And then I fill in what I know. So this is angle U. Angle U is 105 degrees. The side across from it would have to be side U. And now Boone's going to eat, so it'll be extra, extra loud. Then angle N, I don't know. Angle F, I don't know. Side F, I don't know. But side N, because it's across from angle N, is 6. So this one's a little different because I can still use the law of sines because I have a pair, but I only know one angle. Keep in mind that when you are solving for angles, you're still going to need to use inverse. Inverse is always the way to find an angle. So what will happen is you'll have to use sine inverse at the end to find an angle. And so I always kind of just make a mental note of that when I'm going into it. So let's go ahead and find angle N. We're still going to set it up the same. It doesn't matter if they're ABCs or F's, U's, N's, whatever they're going to be. So I'm going to set this up. The sine of 105 over 13, because they always have to be partners, equals the sine of angle N over 6. And I'm still going to cross multiply. It's just going to come out to be one extra step at the end. These will cross multiply, so I'll have 6 times the sine of 105 equals 13 times sine N. Well, I want sine N alone because that's the thing I don't know, so I need to divide by 13, and I'll have the sine of angle N equals whatever I get when I do my math. So 6 times the sine of 105, and then divided by 13. Boom, you could finish eating any day now. So what's weird about this is that is clearly not my angle because I haven't found my angle. This is the sine of that angle. So think back. We did this in 13.4. It would look like the sine of what equals 0.4458. So we've already done this, and what that means is I enter into my calculator sine inverse 0.4458. So I do inverse sine of that previous answer, or I can type it in if you really like typing numbers into your calculator. And that's going to tell me angle N. It's saying the angle that has that as its sine value is 26.48 degrees, because I'm rounding up because of that 5. So up here I can say, well, this one's 26.48. Then don't forget what you know. That's the first thing we found. But now we can find the third angle, because we can take 180 minus the 105 minus the 26.48. That will tell us what is the measure of angle F, because that's the only one we don't know. So we're just using the same strategies every time. 180 minus 105 minus 26.48. So that tells me that angle F is 48.52. So 48.52 degrees. All right, now the only thing that I don't know is side F. Since I can't use Pythagorean theorem, I need to use the law of sines. So I'm going to do that right here. Sine, now Boone's going to go eat Penny's food because apparently he's really hungry. The sine of, and I always go back to the thing that was given, the sine of 105 degrees over 13. Now I'm trying to find little f, so I'll have to have the sine of angle f, 48.52 degrees, over little f. And cross multiply time. So f times the sine of 105 will equal 13 times the sine of 48.52 to get f alone. And this time I'm looking for a side, so I'm not going to worry about inverse. I'm just going to go ahead and put this all into my calculator. 13 times the sine of 48.52, close that out, and then divide by the sine of 105. And I'm getting 10.08. Then I'm going to do kind of my reality check on that, my small, medium, large check. So where's the smallest angle? Right here. Is that the shortest side? Yes. Where's the medium angle? Up here. Is that the medium length? Yes. This is my largest angle, largest side. So now I know the lengths of all the sides and the measures of all the angles. So that, my friends, is 2 solid examples for law of sines. Hopefully that's going to be enough to get you through. There is a go formative, so take your time, do your work on a sheet of paper, unless it asks for it on the go formative, and then just read carefully so that it tells you, it'll tell you how to enter your answer. Make sure you're entering it that way, because what's happening on go formative is it might mark it wrong if it says round to the nearest hundredth and you round to the nearest tenth. And because it's computer graded, I don't always go back and look at every single question from everybody to see if they just type their answer in wrong. So take your time. And if you need a little bit more help, come back and watch these 2 examples that we did together here today. Bye, guys.